Okay, this is the video lesson for Algebra 2, Section 7.4, Properties of Logarithms. So here we're going to use properties of logarithms. Okay, so let's let x equal this logarithm, log, where the base is b and the answer is n, right? X is the exponent, and then y equals log base b, where the answer is n. The exponent is y, right? So you can switch it to be like this using the definition of logarithm. Then, if you multiply these together, right, you would add, since they have the same base, you would add the exponents, right? So then if you take the log of both sides, right, that's the exponent, you would just be x plus y, this log, and then x is this and y is this. This is actually showing you the proof for this property here, the product property, where if you have a log base b with a product, you can split them out to be log base b of the one plus log base b of the other factors. The same with dividing, it just, right, if this is a negative exponent, you subtract. And then if you have an exponent on your answer here, right, the power property, you can just pull that n in front. Okay, and let's see that in action. I'll leave them up there. Okay, so the first thing we're going to do is express these written as a single logarithm. So we're going to condense these logs. So we can see here they both have the same base. So our answer is also going to be log base 4. And then since this 32 is on top, sorry, this is our factor here on top, since this is subtracting, right, this 2 is going to be on the bottom. And so this is our single logarithm, but 32 divided by 2 is 16. Log base 4, 16. And this is actually just 2, right? This is the question asking, what's the exponent when my base is 4 and my answer is 16, right? So this is going to be 2. Okay. And then this one here, you can see we have a constant out in front. So then if we are turning this into one single logarithm, we're going to be moving this constant up to the exponent of our factor here. So log 2x to the 6th plus log base 2y to the 5th. And then we can combine these all to be under log base 2. And then since we're adding our exponents, we can just multiply them, x to the 6th, y to the 5th. So this is log base 2 of x to the 6th, y to the 5th. Okay, that's using properties of logs to condense them. So try these two on your own after pressing pause and then check back for the solution. Okay, so for this one, you can see here it's log base 4, it's just adding here, and so we have a factor times a factor, and that's just 15x squared with a log base 4. Okay, then this one we have a constant out here, so we're going to move that to be the exponent. 6 squared is 36, base 4, and then since this one is positive, it's on top, this one is minus, so that's on the bottom. 36 divided by 9 is 4. Log base 4 of 4 is 1, right? What's the exponent when my base is 4 and my answer is 4? It's 1, right? 4 to the what equals 4? 1. 4 to the 1 equals 4. Okay, so you should get those ones. Don't just leave it like that. You should understand what that means, right? Okay, on. Now we're going to do the opposite. We're going to do this backwards. We're going to expand logs. Okay, so let's take this. We can see this is on top, so this is going to be plus log 4x. This is an invisible plus there. Okay, and then since this is on the bottom, we're going to subtract log y. And then this now can be split up because this is two factors here. So we can split this up to be log 4 plus log x minus log y. Okay, so anything that is on top gets a positive. This is a visible plus, plus, plus. Those two factors are on top, and this one's on the bottom, so it gets a minus. Okay, so this one here, we'll see this x to the 4th is on top, so this will be a plus, so we'll start with that. We don't have to write our plus. We'll just write it log 9, base 9, x to the 4th. And then this is going to be on, this is on the bottom of the fraction, so subtract log base 9 of 729. And then since this is an exponent on our answer, we can pull that 4 out in front. This becomes 4 log 9 of x minus log oops, base 9 of 729. And I feel like this might be, this is actually one I don't know off the top of my head, but this feels like, right, 9 times 9 is 81, times 9 is 729. Yeah, this is 9 to the third power. So 9 to the third power equals 729. So this is saying, right, what's the exponent when my base is 9 and the answer is 729? It's 3. So this is just a 3. So this is going to be 4 log base 9 of x minus 3. Okay? So check. Try these two on your own after you press pause, and then check back for the solution. Okay, here the 250s on top and the 37 is on the bottom, so you just subtract there. And here, this is not, there's 3 to the power of x. X is not, the exponent here, 3 is the base, and 250 is the answer. This isn't an integer, so we're going to leave this here. And the same thing here, 3 to the x equals 37. This is not an integer, so we're just going to leave this. So this is our answer here. Okay, only change it if it's an integer. Like this one here, right, when we split out, these are two factors, 9 and x to the 5th, so we add them, split them up by adding in between. 3 squared is 9, so this can change, this is an integer, so this is a 2. You can change that to a 2. And then this 5 exponent can come out in front, and it's just log base 3 of x. All right, that's the answer there. Okay, last thing, change of base formula. Actually, I don't know why I didn't write this in the notes, but I should have included it. If you have log base b of m, there's something called the change of base formula, and that is for really so you can do it in a calculator, because your normal calculators don't let you just put this in the calculator like that, right? Log base 81 of 27. So what happens here is you can actually change the base, and what that means is this is the same as log m. We're changing the base to 10 here, right? By not writing the 10, it means it's a 10, right? To log m. Log m divided by log b. And this really works for any base. You can change this to a 3, you can change it to a 2. This works for anything. This is the one we're choosing because your calculator, like if you have a calculator at home, it should have a log button on it, and you should look and see if there's a button that just says log. That's your log base 10. And so if you rewrite these with using the change of base formula, that's how you can do it in a calculator. Although you guys have Desmos, and this book was created before you had Desmos, and in Desmos you actually can use Desmos to do this. So I want you to just know that this change of base formula exists, and you should write it like this, but you can put it in Desmos. There's a button on, under the functions that's log A, and then when you click that button, it'll allow you to put the 81 down here and the 27 up here, and it'll just give you the answer. But let's use the change of base formula. I do want you to know that this exists, so you would change this to log 27 over log 81. And so on my calculator that I have here, I'm going to click the log button, and then I'm going to click the 27, and divide it by the log button with the 81, and then you get a decimal. This is actually 0.75. Okay, or 3 over 4. And so that's how you use it, to help you use it for a calculator. Again, if you look on your Desmos, you can also do that. Just click that in here. So what I think you should do is actually put in Desmos, do this in Desmos, see that you get this, and then also find this button that has that little A, and then actually type this into Desmos, and you can see that they're the same thing. And it's pretty cool. And when we learn natural log, we'll learn that later, and you'll probably use that more than even this log button, but that's not quite yet. So here, the way that I remember is just that this one goes on the bottom, because it's the base, bottom base. Log 36 over log 5, put that into your calculator or your Desmos, log 5, and this is a long decimal. I usually just want to see it rounded to 4 decimal places, 2.2266. But if it doesn't say, you can do whatever you want. Okay? There you go. But I do want to see this, though. Even if you do type it into Desmos just like this and get the answer, I do want you to write this so I know that you know that the change of base formula is this. And I will also be giving you this formula, so shouldn't be too taxing. So press pause and try these on your own and then check back for the solution. Okay, so here you get like 1.666666, right? And that's just a fraction, right? 5 over 3. And then this becomes 2.0850. All right, that's it. Time for practice. Enjoy.